So, Mr. Nair, are you there?
Yes, sir.
So the link will remain same throughout.
Yes, sir. Sandra has informed the class, and
Yeah,
we have forwarded the link.
yeah. So it will remain the same. Still the students are joining.
Sir, we can start the lecture.
Okay. So we are discussing processing operations.
Yes, sir.
So you all know now what is property enhancing, what is surface processing. Shaping process means which gives the shape. So solidification process, basically it is casting. Particulate processing, it is nothing but the molding process. Deformation process is nothing but your rolling and drawing. And metal removal process is nothing but your lathe, milling, etc. Hello, can you call at 1:30 please? 1:30. So solidification processes. So you have casting is nothing but a solidification process. So here you have a molten metal, molten that is metal which is melted in a furnace. Okay. So you have a big furnace which is called as a cupola. So in cupola furnace, the metal is melted. ये सब भंगार वाला जो metal लेके जाते हैं ना सब भंगार वाला. So that all goes to the foundries, big foundries, and all that material like लोखंड है, stainless steel है, iron है, there they separate it and melt as per the chemical structure or as per the chemical specifications that we want. Okay, and then from that cupola is a big furnace. Okay, from that furnace the metal is collected in a ladle. Ladle is nothing but a drum, metal drum, right? And then this ladle is used for pouring the metal in a mold, and this mold is made up of sand. In casting the mold is called as the sand mold. So sand mold will look like this. Like let us imagine that this is what a piece you want. It's a solid casting and you will have a depth. So say this is say 100 mm and say this is 75 mm. So you will have some depth here, okay, which is not shown here in this view. Now this is called as the sprue, down sprue. The sprue collects the material to the mold and form the ladder. So this is called the sprue. Then this portion is called as the runner. This is called the runner. And then from runner, where the material enters inside the cavity, that is called as the gate. जैसे कि हम लोग का जो घर का जो गेट रहता है दरवाजा, from where we enter. So similarly, here we have a small gate here which is not shown in this drawing. So sprue, runner and gate, these are the unwanted portions which you need to trim it after the solidification. Right? So here the cycle is like you have a molten metal which is obtained from a furnace in a ladle, and then it is poured inside the cavity, and then it is allowed to cool so it solidifies, and then once it solidifies then it is taken out. This solidified portion is taken out. How it is taken out? You have to break this sand which is surrounding this cavity. You have to break this sand. Okay, once this sand is broken then you will find or you will get this metallic piece. Earlier, this casting process was only confined for the cast iron, material cast iron, but nowadays castings can be done for any material. You take about steel casting, stainless steel castings, MS castings, you talk about brass, bronze, aluminium, any castings, any material cast can be cast. Then you have particulate processing. So particulate processing may we have starting materials, that is raw material will be metal or a metallic powder or a ceramic powder. So here the limitation of this process is you should have a metal powder or you should have a ceramic powder. Metal मतलब mild steel, carbon steel, high speed steel, alloy steel, stainless steel. These are called the metal. सिरेमिक मतलब जो हम लोग घर में जो सिरेमिक यूटेंसिल्स यूज करते हैं और you might have seen the power transmission lines में you might have seen the brown color का insulators, those are all made up of ceramics. You may be knowing ceramic tiles. Okay, so the limitation is that you should crush this metal or you should crush this ceramic into powder, then only you can use this process. Okay, so you have a crushed metal or you have a crushed powder, uh, ceramic powder or metal powder, which is pressed in between the two punch. Now here, this process is called as the powder metallurgy. This process is called as the powder metallurgy. The same principle is applied for your pharma industries. So you everyone must have seen the tablets, pharma medicinal tablets, like say Dolo Bolo, aspirin Bolo, no, or any other. It can be in a capsule shape, or it can be in a round shape, or it can be any shape. It can be. You might have seen the small kids का छोटा छोटा chocolates, हम और लिमलेट का गोली, you might have seen. You might have seen the various shapes, chimney, kaula. You might have seen the small biscuits also, chota chota biscuits, uh, which are of various shapes, elephant shapes, kaula ka shape, chimney ka sparrow shapes. Hmm. So these biscuits, these limlet ka goli, or even these medicinal capsules or medicinal tablets are produced by this process. हाँ, by pressing. इसमें कैसा रहता है, दिस इज अ डाई, डाई का शेप रहता है. ओके, डिपेंडिंग अपॉन द टैबलेट का शेप. सपोज इफ यू वांट अ राउंड टैबलेट, राउंड मेडिसिनल टैबलेट और ओवल मेडिसिनल टैबलेट, देन जो डाई का जो इंटरनल शेप रहेगा दैट विल बी राउंड, that will be elliptical. Okay, that depends upon the shape of the tablet. Let us assume that this die has a round shape. Obviously, the punch will also have the round shape. There are two punches. Usually, the lower punch is stationary. Okay, so assume that lower punch is at this height, which has already gone inside the die. Assume, imagine that this upper punch is somewhere here at the top. Upper punch ऊपर है. So how does the cycle begins? You have a die, you have a lower punch, और इसमें अभी कुछ भी नहीं है. It is vacant. So what we do here, we put the powder here. We put the powder, metal powder or ceramic powder, of the desired weight or of the desired volume, desired quantity. In medicine or in chocolate industries or in biscuit industries like say Parle G, which has a plant at Ville Parle, which has been shifted now. So they have lots of products like Parle G biscuits, Crack Jack, then Monaco, so many brands they have. They also have different type of chocolates, Cadbury chocolates and whatnot. So these biscuits and these chocolates are made by these techniques. जो बिस्किट का पाउडर है, that that you will first pour inside this, okay, and then upper punch will come down and it will press, and it will press. Hmm? It will go down till the desired thickness. Suppose if the thickness of this, say this is a round tablet, suppose the thickness of this round tablet is say 5 mm. Okay, so the upper punch, the clearance or the gap between upper punch and lower punch will be 5 mm. Okay, once it is compressed, okay, then upper punch will go up and then lower punch will eject this out. Okay, lower punch will push these tablets up so that this component can be ejected out or can be taken out. Remember here this quantity in terms of volume or in terms of weight is very important, because these are FMCG, fast moving consumer goods industries. Even the soaps, हम जो the soaps which we use for bathing, for bathing, are made by this technique. So weight is very important. Imagine there are lakhs of tablets, there are lakhs of chocolates which are produced every day because the consumption is very high. Chocolates, 1 lakh, 10 lakhs chocolates are produced per day. So even if the 1 gram, suppose, even if you put 1 gram more in this, 1 gram more chocolate, so 1 gram into 1 lakh, so that will be 1 lakh gram. So 1 lakh gram will be how much? 100 kilogram, 100 kg. 1 lakh divided by 1000, so 100 kg. So consider the material costs. So you are giving 100 kg more to the customer. Okay, so this is a loss to the company. At the same time, suppose if the chocolate ka weight है suppose 10 grams, so you cannot pour 9 grams or you cannot pour 8 grams. That will be cheating. It will be governed by the rules, because this government of India or food industry or food corporation of India, they have a close monitoring, whether if you give, if suppose if you are a producer like Parle-G, if you are giving more, that is 15 ग्राम का चॉकलेट है, if you are giving 15.5 grams chocolate, no problem, okay, but then that is a loss to the industry. But moment you are giving 14.5 and if you are adding 15 gram, then the customer or FCI can sue the industry in the court stating that you are cheating the customer, you are giving less weight and you are taking more money. So that's why this weight is very important. So here the weight cannot be controlled precisely. So that's why we go for injection mode, or some other kind of techniques for manufacturing these soaps or for chocolates. Okay, so this was just to illustrate how the pressing is done. This is done in normal our press. Usually in normal press, the top punch is moving, but in this, the top punch as well as lower punch both are moving. Top punch will compress it and lower punch will eject the product. Then deformation. Yes, anybody? Somebody wants to talk?
Mr.
Anybody wants to talk?
Sir, how does it become such a solid structure?
This is, you have to speak little loudly. This
Sir,
is in
how?
the solid form only, no? This is not in the liquid form. The metal is crushed. Suppose if you take a metal, it is crushed into powder form, or the ceramic is crushed into powder form. Okay, and then इसको press करते हैं. तो press करने के बाद क्या होगा? It will become solid, no? And then it is heated. That is what is called the sintering. So it becomes very gut, rigid.
Okay, sir, understood.
So basically, it is not at all in the liquid state. It is in the solid state itself, but it is in the powder form. And that is the limitation. अगर आपके पास suppose एक metal का flat है, let us talk about stainless steel का आपके पास एक flat है, 200 by 200 by 20 thick. So you cannot press that. वो आपका जो stainless steel का flat है, you will have to crush it into powder. And then only you can compress it into the desired shape. अभी ये shape, this is round, but it can be oval also. Okay, or it can be any fancy shape like love, heart ka shape, or sparrow, or rabbit, hmm, any shape. I know when I was child, when I was very king, I used to fight for that sparrow. I used to like that sparrow ka tablet and sparrow's biscuits. So whenever I used to go to the shopkeeper, so 1 rupees ka biscuit de do. So I used to take only wo sparrow wala biscuits. So these biscuits, chocolates are made by this process.
Okay, sir, thank you.
Most Then, Mr. Khan is there, no? Sakib, Sakib. Yesterday I asked you, no, Mr. Sakib,
Yes, sir.
that how you will manufacture egg curry. So,
So there were too many processes, and then there was something for different for metals and different for composites. I don't know which one you asked me to search for.
sorry.
So there were two different methods, one for composites and one for metals, like different processes.
For metal, suppose if you want to make egg shell like component from metal, so how you will produce?
So I don't know, so
Okay,
maybe casting. I tried searching, but there were too many results.
okay, ठीक है, no problem. There is no process to make eggshell. Only nature can make it.
Okay.
Okay. So you are
Sir,
right.
we can do it like first we can blow it and then we can put a metal on that hole and then rub it
First
to
you
make.
can what? Come again?
First we can make egg-like shape with a hole by blowing inside it, and then we can uh, like sand, put metal on that hole and sand that hole.
What is this process called as?
I don't know the name of the process.
So you can just make two semi-spheres.
It is something similar to the blow molding, but in blow molding, what happens? At the top, there will be a mark.
Yes,
Understand?
yes, yes, sir.
That is
So
one thing. And second thing is blow molds and injection molds, they are made into two halves. Okay? They are made, the mold is made into two halves. Those two halves first come together. Mold का जो cavity है ना, mold, it is made into two halves. The two halves come together, and then only the metal is injected or metal is blown. So whenever these two halves are meeting, so there you will see a small line which is called the parting line, and that will be visible. Okay? Yes,
so
Sakib, you will,
after sanding, it won't be visible, right?
after
Sanding.
after sanding, but you cannot get a finish. What I had asked, that there should not be any parting line. No,
Okay.
no, any finishing process you use, the parting line can be, you can identify unless you go for super finishing. Yes, Sakib, you wanted to ask something.
Sir, or we can use metal sheets and like curve it into cones and then do like smooth the surfaces and then you can make two semi-spheres and then attach it by welding.
But whenever you attach, you do it by welding, brazing, soldering, but on the surface it will be visible. No, my condition was that there should not be any marks on the surface. Nothing should be visible.
Yeah.
There is no processor. It's only this thing. No, no, only nature can produce. This is something like a hen conceives and then she lays down the egg. Okay,
Okay, sir.
so still you can give a thought. I am not demotivating you.
Okay,
It
sir.
can enrich my knowledge also. Maybe some technology. Now, forging and extrusion. So now this is what is called the forging. Okay, where the component is made red hot. This is your die, lower die and upper die, and the lower die and upper die will correspond to the shape of the component which we want. Okay, so initially we are keeping a slug. Slug means what? It is a raw material which is kept inside this die. Okay, and then you press it. So now when you press it, that component will take this shape. Now since it is in hot condition, the material will flow easily. So the less forces will be required to press. So this is your forging. Okay. Then extrusion, like I gave an example of आपका toothpaste. So extrusion is nothing but you are pushing the material. So imagine a toothpaste. I am Colgate. I am not branding for Colgate, but Colgate toothpaste आप press कर रहे हो. So the paste will come in this form. So that is what is called as the extrusion. Okay. So these are the different components. Uh, this is V and F is nothing but this is the velocity and this is the force. Then in case of extrusion, you have a ram which is moving with some velocity and it applies some pressure. This is called as the die. and die corresponds to the shape, the desired shape. Like suppose if you want 2 mm or if you want 5 mm, then there will be a hole of 2 mm or hole of 5 mm. This is of course a hardened material, this die, because it is subjected to the hot material, and if it is of soft material, then it will wear out faster. Material removal process, I hope you are familiar. This is a lathe. In lathe, the component is rotating and the tool moves to and fro. Remember. In case of milling, the component moves, that is the workpiece, moves to and fro, and the tool or the cutter rotates. In case of lathe, the tool reciprocates and the component rotates. There are exceptions. There is something called the sliding head. Sliding head. So sliding head may your tool rotates. In case of I am talking about sliding head lathe, but don't get confused. Sliding head lathe may tool will rotate and workpiece will remain stationary. Now the most important things what you have to remember here. What do you mean by feed? Feed matlab it is the rate at which, or it is the velocity at which the tool moves across the workpiece. Is it clear? This is what is called as the feed. And then feed, the unit of feed is millimeter per revolution or millimeter per minute. It is nothing but velocity only. What is the unit of velocity? It is meter per second, but here we express in millimeter per revolution or millimeter per minute. What does it mean? Millimeter per revolution. Let us take example, say if I say my feed rate is 0.2 millimeter per revolution. It means in one rotation of the workpiece, the tool will move by 0.2. If I say my feed rate is 100 millimeter per minute, it means the tool will move 100 mm in a minute. Now I'll ask you one small numerical. Suppose if the feed is 0.2 millimeter per revolution, 0.2 millimeter per revolution. Anybody can answer this. If the feed rate is 0.2 millimeter per revolution and if the spindle is rotating or if the spindle speed is 100 rpm, 100 revolutions per minute, so what will be the feed rate in millimeter per minute?
20 millimeters per minute.
Yeah, correct. Huh? It will be 20 millimeter per minute. Very good. All of you agree?
Yes, sir.
Yes,
Since the
sir.
numericals are based on these formulas, so that's why I thought I will ask you this question. So in lathe, there are forces, cutting forces in all the three directions, in X, Y, and in Z also. In milling also, the forces are in all the three directions, X. X means like this, longitudinal. Y is perpendicular to that, that is transverse, and Z is this way. So lathe या milling, the forces are X, Y, Z. Whereas in drilling, there is only one force, that is in this direction, in Z direction. Because remember, drilling machine is meant only for axial thrust. Drilling machine spindles are designed, or the bearings which are used in drilling machine spindles are designed for taking only axial thrust. You might have seen in small scale industries drilling machine being used for milling machine as a milling. Many students who are practically exposed, they might have seen वो क्या करते हैं छोटा कंपनी में ड्रिल की जगह एंड मिल लगाते हैं मिलिंग कटर और मिलिंग मशीन जैसा यूज करते हैं क्योंकि ड्रिलिंग मशीन का जो टेबल है वो ऐसा भी मूव होता है एक्स में और वाई में भी मूव होता है बराबर है और जो ड्रिल है वो अप डाउन मूव कर सकते हैं So why not to use as a milling? But remember, in milling, there are forces in longitudinal direction as well as transverse direction. So if you are using drilling machine as a milling, then your drilling का जो spindle है, machine का spindle है, that will get spoiled within a years, because only thrust bearings are used in drilling machine. There are no taper roller bearing, there are no radial bearings, there are no ball bearing, only thrust bearing. So the spindle will get damaged, and once the spindle gets damaged, then the machine cannot be used because you will lose the accuracy. If your spindle starts rotating eccentric, डैमेज मतलब क्या, अंदर का बेरिंग्स खराब होएगा तो योर स्पिंडल विल मूव आउट, इट विल रन आउट, इट विल rotate out, so you will not get desired accuracy. It is always a good practice that we have to minimize the waste when you are using the shaping process, like say lathe. Okay. Lathe. Let suppose if this diameter to be turned is 20 millimeters, say this diameter to be turned is 20 mm, then the raw material which you will order should be around 22, 2 mm or 3 mm more, or at the most 1 inch diameter, that is 25 mm. But if you are using 50 mm round bar, and from 50 mm if you are turning it to 20 mm, so that means is there is a great waste. Not only in terms of material, आपका material तो waste हो रहा है, but आपका machining time भी ज़्यादा लग रहा है. Your machining time is also increased. Your energy is increased. Energy consumption, electricity bill will rise, which will increase your overheads, which will increase your product price. Not only this, your cutting tool will also get blunt, and your tool cost will also increase. Unnecessarily you are paying extra to the workers, because the work which can be done in 5 minutes, it is taking now half an hour because the stock removal is more. So there will be a lot of overheads and your price of the product will increase. So you have to minimize. So in this case, what we do, we forge this component keeping only 2 mm material. Like say if my this diameter is 20 and if this diameter is 25 or 24, I will do forging. In forging may I will keep this diameter as 26 and I will keep this diameter at 22. Only you have to see that there is a quantity, because for forging bolo, casting bolo, molding bolo, you have to make a die. Okay, so you cannot make a die if you have to produce only one piece or two piece. The die cost has to be justified. You have to get it back. The money which is required for making the die has to be returned. You have to get the return very fast. But if it is only one or two pieces, okay, and if in case if 25 mm rod is not available, then you can go for the next higher size 30, but directly don't go for 50 mm. This is what I mean to say. So molding and particulate processing operations waste are very little. Okay, these are the various methods of making a simple part. Like this is casting or metallurgy, this is your forging, this is your extrusion, this is your machining. देखो machining, how do you identify this is the machining? ये ऐसा raw material दिखाया. This dotted line is nothing but the size of the raw material, and from this you are making this. This is dotted line and this is continuous line. And in case if want to avoid, like suppose you have only two pieces and you want to reduce the scrap, then what you can do, you can take one small piece like this and one piece like this, second piece, and you can weld it. Okay, so you will have a welding cost, but आपका जो scrap है that will be minimal. So you have to have a trade-off what to do. Okay, so that will all depend upon the economics के ऊपर it will depend. ठीक है. Then material removal process can be further. The weightage of this whatever I am taking is 4 marks. Okay. इसमें in this subject the investment is more and the returns are means returns are also good, but for the good returns the investment is very high in this subject. You can get 75, 78, huh? And this being online exams, the students are getting even 78 also. Since 40 marks MCQ and 40 marks subjective. Okay, so MCQ they get 40 on 40 and subjective may they lose 1 or 2 marks. Or sometimes the policy is also there not to give 100% in subjective. But of course, if it is properly written, we don't cut the marks unnecessarily. Hmm. But what I'm trying to tell here that here if you want to score or if you want to have a good returns, then your investment is huge in this subject. Like मैथ्स में इतना नहीं है, इन्वेस्टमेंट कम है और रिटर्न ज्यादा है. I mean investment कम मतलब comparatively. Don't misunderstand, comparatively. If you talk about mass and production process, if you want to get the same returns 100%, obviously you have to invest. Means you have to invest matlab you have to study more in production process. So MR material removal processes is classified as conventional machining, abrasive process and non-traditional. Conventional आपको मालूम है turning, drilling, milling, shaping, planing, slotting, all these are conventional. Abrasive मतलब grinding, then other abrasive processes like lapping है, super finishing है, honing, HONING, grinding, honing, lapping, super finishing. These are called as an abrasive process where abrasive is used. Abrasive मतलब it's a silicon oxide का particle. Silicon oxide है silicon carbide. Silicon oxide is nothing but आपका alumina, which is available at the stand. I mean, this C stand, beaches. So from that you make this abrasives, SiO2, silicon oxide. Then non-traditional machining में you have mechanical energy processes. Then you have electrochemical. Electrochemical में electric current as well as chemical is used. Thermal में heat is used, and chemical machining में only chemical is used. So this is electrochemical machining is also called as the ECM. ECM. Mechanical energy में EDM, that is electro discharge machining. Okay. So now in machining, now this is another 4 mark question. So 4 plus 4 if you study this cutting tool well. Okay. So in this cutting tool, additionally they will ask for the nomenclature, that is how the tool is specified, which is not covered in this file. Okay, this is not. So this is a cutting tool. This is your lathe machine. Now these are the various parts of the cutting tool. ये आपका workpiece है, and this is a chip. All right. Now this portion is called as the flank, this portion is called as the rack face, and जो alpha जो दिख रहा है that is called as the rake angle. Okay. Now rake angle can be positive, negative, or it can be zero also. Like this is now negative rake angle. See, this is your positive rake angle, and zero means it will be exact. Alpha is equal to zero means tool will be like this. It will be perpendicular to this surface. Okay. So when to go for positive, when to go for negative, that we'll study in metal cutting, that is in module 4. Okay. Then this angle is called as the relief angle. Relief angle. The purpose of relief angle is that the flank should not touch the workpiece. ये जो flank है, it should not touch the workpiece. Otherwise, What will happen? It will rub the workpiece, and workpiece finish will get damaged. At the same time, there will be flank wear also. So that's why we have to have relief angle. Altogether, there will be 6 angles on the tool. There are 6 angles, six, छः, which are ground on the tool workpiece, on the tool, which we'll see in module 4. Now there are certain, why you have to go for machining? Why not always go for casting or forging when there is a scrap reduction or when the scrap can be reduced? There are certain things where the answer is machining only. Huh? You can only go for machining. So like this, if you want to have a threads, then you cannot cast or you cannot forge, or even you cannot do powder metallurgy. Only you can do machining only. Machining is the only answer. If you want accurate round holes, we talk about G6H7. Accurate round holes matlab when there is a very close relative motion, that is say cylinder and piston. Piston is going inside the cylinder, okay, many times, to and from. If the piston hole size is more, sorry, if the cylinder hole size is more, then the piston will bobble inside that. Okay, piston will not guide properly. So there is very less clearance between cylinder and piston. So the holes are ground, they are honed. Okay, so if you want that much accuracy, then you will not get that accuracy in casting, forging, or powder metallurgy. You will always get a rough surface. Even injection molding or blow molding also cannot give accuracy within 20 micron. 20 micron is nothing but 0.02. So if you want a good dimensional accuracy and a good surface finish, then machining is the answer, right? But there are the disadvantages also, like wastage is more, chips which are generated is more, and it is time consuming. More and more time is required here. Okay, so machining will give you final shape, dimensions, finish, and some geometric details. These are the different machining processes like turning, drilling, milling, shaping, broaching, sawing. These are called as the machining. Turning process you are familiar. Feed motion, I told you what is called as the feed. Alright. Drilling, I told you what is the purpose of this. This ये जो आपको दिख रहा है, this is for the flute. What is the purpose of this flute? Can anybody tell me? Flute, बांसुरी का flute. Can anybody tell me what is the purpose of this flute? I hope you all there. सिद्धार्थ, बोलिए. Are you there?
Yes, sir, I'm here.
Yeah. What is the purpose of the flute? This
Sir,
flute.
purpose of the flute is to effectively remove the waste that is coming out of the machining process. Like,
Good. It is to guide the chips. जब हम लोग ड्रिलिंग करते हैं, so there will be chips, बराबर ना, which will come out. Okay,
हाँ
so
sir.
assume करो कि this drill is suppose solid. Okay, assume it. There are no fluid, and you are trying to push inside. So when you're trying to push inside, there is a point here. Okay, so obviously it will cut, and there will be chips. Now, if it is completely solid, then where that chip will go, there is no way for the chips to come out. Correct? So for that, the flutes are cut. And what will happen? Suppose if there are no flutes, and still if you are trying to drill, what will happen? Can you tell me, Siddharth? Did you understand my question?
नहीं सर, एक और बार रिपीट कर सकता हूँ?
ये सपोज सॉलिड है, दिस ड्रिल सॉलिड है, देर आर नो फ्लूट, इसको फ्लूट बोलते हैं. खड्डा
सर
दिख रहा
फ्लूट
है.
नहीं होगा तो बेसिकली हीट के वजह से द मटेरियल कैन ब्रेक, वो एक प्रॉब्लम हो सकता है.
अभी क्या होएगा, चिप बाहर निकलेगा नहीं, बराबर है.
हाँ सर.
लेकिन हम लोग दारा सिंह की तरह बिल को अंदर दबा रहे हैं, बराबर है, नीचे दबा रहे हैं, कट कर रहे हैं. So there is axial thrust which is generated by the operator, as well as there is a chip force, chips which is trying to come out. So in this case, whichever is weaker, that will break. If the drill is weaker, drill will break. If the workpiece clamping is weak, then workpiece will fly off. Either of these. ठीक है? Darwin's
एंड
theory.
सर
हाँ.
अगर दोनों का लाइक हम बेटर यूज कर रहे हैं लाइक दोनों हैवी मशीनिंग के लिए यूज कर रहे हैं सो लाइक कैन द वर्क पीस जस्ट गेट डैमेज्ड
हाँ, yes, workpiece. Suppose if अगर ये drill suppose carbide का है, बराबर है ना? And if you are trying to push, and this carbide drill is stronger or harder than workpiece, so your workpiece will get damaged. It will break. Workpiece will break. Okay? Shall I go
हाँ
ahead?
हाँ सर
Yeah. Then you have milling. So milling में, as I said, the cutter will rotate and the workpiece will move to and fro. And this is what is called the feed motion. This is called the feed motion. अभी feed का मैंने दो यूनिट बताया था. एक था मिलीमीटर पर रेवोल्यूशन और दूसरा था millimeter per minute. In case of milling, there is one more unit which is called as the millimeter per revolution per teeth. How many teeth you can see here? One, two, three, four. Okay. So generally there are two T's, four T's, or maximum six T's. So here the feed is expressed in millimeter per revolution per teeth. Now Siddharth. Now same, if my feed rate is 0.2 millimeter per revolution per teeth, and if there are four teeth, and if the spindle RPM is 100, what will be the feed rate in millimeter per minute?
सर बेसिकली मल्टीप्लाई कर देंगे 0.2
हाँ,
मल्टीप्लाइड बाय 4 मल्टीप्लाइड बाय
हाँ तो करो
100
कितना
80
आता है बोलो
80 आएगा
80. Okay, so you are able to multiply by number of ticks, so you got that properly. So you need to study these relative motions, like in case of turning, it is rotating and this tool moves to and fro. In case of boring is nothing but enlarging the hole, hole को बड़ा करना. Okay. And the other use of boring is that it gives you good finish and good size. तो boring में क्या होता है, ये this is a holder और holder में ऐसा tool लगा के, this is a tool. Okay, and this tool can be moved in and out depending upon the size of the workpiece. ये जो bore size, अगर मेरे को 20 का चाहिए, अभी 22 चाहिए, तो टूल को मैं बाहर निकालूंगा. इधर स्क्रू है, स्क्रू को लूज करने का और टूल को बाहर निकालने का. हाँ, एट द डिजायर्ड. फिर हम लोग स्टार्टिंग में हल्का सा कट लेने का और साइज चेक करने का, 22 बराबर आया है कि नहीं. अगर नहीं आया तो और टूल बाहर लेने का, अगर ज्यादा आया तो टूल को अंदर लेने का. सो दिस इज मैनुअल एडजस्टमेंट. मैनुअल एडजस्टमेंट इज नॉट बोर, सो दैट्स व्हाई वी हैव समथिंग कॉल्ड द माइक्रो बोरिंग बार. माइक्रो बोरिंग बार में यू कैन मूव द टूल. यहाँ पे ऐसा एक रैक एंड पिलियन जैसा डायल रहता है छोटा, तो यू कैन रोटेट बाय एलन की, and you can rotate so that your tool can move in and out precisely. ये ड्रिलिंग है, ड्रिलिंग में ड्रिल इज रोटेटिंग एंड ड्रिल इज मूविंग अप एंड डाउन. ठीक है. I'll just take 2 minutes so that we can finish with this. So planing में what is the relative motion? Planing में again your tool is stationary and your workpiece reciprocates like this. At the same time your workpiece will move in this direction also. हाँ, so इसको बोलते हैं stroke planing में. अभी एक stroke मतलब it will go from here, it will go to other way, other side, and again it will come back. Okay. So उसको बोलते हैं डबल स्ट्रोक. सिंगल स्ट्रोक मतलब यहाँ से यहाँ, डबल स्ट्रोक मतलब यहाँ वापस अपनी जगह पे. सिंगल स्ट्रोक मतलब like suppose if you are staying at Santa Cruz station, Santa Cruz to Father Agnew, and Father Agnew to back to again Santa Cruz, that is a double stroke. So now workpiece will also move in this direction so that the entire surface can be machined. Milling में again you have cutter rotating and workpiece is fair, like this. This is your grinding. In grinding, your wheel is rotating and your workpiece is also rotating. Okay, so grinding is the only one operation जहाँ पे आपका tool भी rotate होता है और workpiece भी rotate होता है. ठीक है. Then now you know, now these are very all simple, like suppose now Siddharth has calculated. Now suppose Siddharth, the last question to you and we can pack up. Like suppose you have said Now 20 millimeter per minute, correct? No, is the feed rate. Now, if I want to machine, if I want to turn a lane 100 long, so how much time it will take? है क्या गया? हेलो मिस्टर सिद्धार्थ.
हाँ सर, वो
हाँ
फॉर्मूला देख रहा था एक
हाँ, how much time it will take? What is the feed rate? Hello.
2 millimeters per T.
20 ना, 20
20,
millimeter.
20.
0.2 millimeter per revolution, that is the feed rate. Spindle is rotating at 100 rpm. So what is the feed rate in millimeter per minute?
20.
20 millimeter per minute. Now my question is, I want to turn a length up to 100 mm. So how much time it will take?
5 minutes.
अभी सिद्धार्थ, तुम क्यों इतना सोचने को लगा? ये इतना चिराग ने फटाफट बदल.
100/20.
20 मिलीमीटर पर मिनट मतलब क्या, 1 मिनट में 20 मिलीमीटर जाता है, बराबर ना?
हाँ सर, हाँ वो
तो 100
यूनिट्स में
millimeter आपको
कंफ्यूज हो गया.
टूल जाना है तो it will take 5 minutes. So did you use any formula? No, isn't
नहीं
it?
सर, नहीं सर, वो
So that's why
यूनिट्स.
don't remember this formula, ठीक है? But what you can remember that if you want to find out the machining time, then machining time is equal to what is the total length to be machined divided by the feed rate or divided by the velocity. Now units you have to take care. अगर आपने total length मीटर में है तो feed rate भी मीटर पर मिनट में ले लो या मीटर पर सेकंड. You have to take care of the units. Understand that you know very well. It is nothing but velocity का formula. That's all. Okay. ठीक है. हाँ. We'll call it a day. Tomorrow again we are meeting at 12:30 and with the same link. So don't let me wait. Huh?
हाँ सर,
Okay.
वो आज थोड़ा कंफ्यूजन हो गया था बेसिकली.
Okay.
हमको लगा दूसरा कोई लिंक आया, कल से
Okay.
नहीं होगा.
Okay. Thank you so much.
थैंक्स अ लॉट.
Thank
Thank
you,
you,
sir.
sir.
Thank you, sir.
Thank you,
Thank
sir.
you, sir. Bye, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you.
Thank you, sir.